So you mentioned that there's no garbage collection and no runtime Rust plans to add anything to that?
So have you heard of the Beam garbage collector for C++? It's kind of in the library. Rust will have an equivalent. We might be adding some kind of hooks into the compiler to give it a little bit more information than Beam has and kind of like make it a little bit faster. But even then, like I said before, I should mention, kind of like kind of a different point, is that in Rust, it's not just ownership. Making things like graphs is kind of painful, because you either need to go into like a single unsafe code to the unsafe pointer to a graph, like in the previous node, or you need to use reference counting. And we have, it's kind of like Swift's arc, where it's like RC, there's no cycle collection, it's just RC plus weak pointers to work with cycles. So, but GC is potentially the solution for making graphs in Rust, and we intend to support it eventually in some way, but for now we're getting along really well. I should mention a historical note is we used to have it in the language itself. You can name it for a small time ago. We had these little curly Q pointers, like they were @symbol pointers, and they were intended to be used kind of like, hey, when you need garbage collection, use these, and then when you don't, when you get faster, you just take those out and put in like actual like linear pointers, and that was a huge pain in the butt. It turns out in practice. So we took all those out and realized we didn't really need those. We got along so far just with our current unique pointers and with our bar references, our check lifetime references, that it really wasn't ever an issue. I think that's even, I'm not a C++ user, but I think it's mirrored the experience of people in C++11, where C++11 has both unique pointer and shared pointer, where unique pointer is like our unique pointers and shared pointer is like our RC pointers. And they really kind of discourage our shared pointer in favor of unique pointer whenever you can. Because, and again, we offer, our version of unique pointers offers more guarantees, safety-wise and performance-wise, than C++ do. So that's one of the places where we can actually do better in C++, both safety and performance-wise. So yeah, long story short, GC will come one day in a library though, and it's entirely not mandatory.
And you don't seem to need it so far?
So far, we don't care. It's pretty much all safe. Let's get someone else.
So what do you hate about Rust?
I think our module system sucks. No? What do you think? It's a divisive topic. I think it's too complicated.
It is a point of much complication sometimes with the module system. It's one of those where everyone who understands it says that it's perfect, but that set of people is very small. So it's we are working on this, specifically the module system. We have made a lot of changes to it to make it more approachable and more kind of like first time you use it, it makes more sense to kind of the compiler will you'll still hit bunches of errors, but the compiler will kind of walk you through the errors and say like this is probably what you want, what you mean, and help you structure things.
And for a lot of C++ users, the fact that we have one at all is just like they don't care. They just care that we don't have headers. So they're like, oh my god, it's a godsend. I think our compile times are still too long. We're working on that. We've always been working on that, but I mean.
So that's a little nuanced in that our compile times are very high, but the reason for that is because if you think of LTO in a C++ term, where basically you can concatenate a bunch of C++ files and then you compile that, that's basically what we do. We do that by default. So we don't have incremental compilation the way C++ does, where we don't compile one file at a time. So when you update a file, you have to recompile the whole library. So this gives us a huge number of benefits. Like our compile times are way lower than C++'s. Our optimizations are really, really high as a result of that, because you can do so many procedural optimizations. But as a result of compiling new libraries at a time, the compile times are still kind of high. And it is totally, unlike C++, which is totally dominated by header files, and like reading and parsing and optimizing all of them, our compile times are totally dominated by LVM optimization passes. So it's totally surmountable. It's something that we can make better, but it is a pain point today.
And other than that, it's mostly just there's some syntax stuff I'm not the biggest fan of. I mean, like, I could live without semicolons, but I really don't care. Some people will argue endlessly about this. I really don't care. And there's some other like aspect of the grammar where I'm not like the huge fan, but there are good reasons for it, like that we need type, the double colon before types in expressions. So that's kind of gross. But I mean, that's really, if you knew what I was talking about, you wouldn't really care because it doesn't come up very often. Type inference goes a long way in terms of getting that away, out of the way. Other things that I don't like about Rust. I don't know. It's all really cool. It expands my mind, which is, I really like. The community is really friendly. So, developers have good taste.
Is there a REPL for Rust?
There is, so the best that we have so far, we have this Playpen, just like this, and then if you go on IRC, you can access this from IRC. It's a bot called RustI, and it can be like, print line, a little P-brew, oops. So,
Oh, okay.
in terms of an actual REPL though, LLVM does have a just-in-time compiler support that we've been trying to leverage for a while now to kind of like let's do this kind of REPL style thing, remember your history and all that kind of stuff. That's really, their support's really bad, from what I understand, in terms of like being very immature. So it always kind of bit rots after people kind of like get satisfied with it and have to move on. At some point, I mean, like you can make REPLs for C, so people have made like Clint, I think, is that I don't know Clint. What's it called? What's that? Like REPL plus from like the people who made the giant hadron collider. Was it? I don't know. But eventually it will come, people will deem it necessary. For now, I just kind of like write it, kind of just like code, Control-Z, run, compile. There are different ways of doing it too. So I mean also, we support like shebangs in Rust code too, so if you want to like know it's kind of like turn it executable, any kind of a given file, and then like we do like a shell code where it's like run this, compile and then run. That'll work too. So
if someone wanted to get involved with the Rust community, writing libraries or contributing to the language itself, how would you tell them to start and go about doing that?
if someone wanted to get involved with the Rust compiler community, I recommend that they first subscribe to the developer mailing list, which is, let's find out if you can just Google Rust mailing list. Let's see if it's the first result. Rust dev info page, the first non-ad result, anyway. So you want to subscribe, typical kind of like login stuff, email address. So, and then once you do that, we have some bugs I showed you before. Our GitHub tracker. We have this issue tracker. If you're familiar with GitHub, at least they're familiar with you. I think we used to have a tag for easy issues, but that might have gotten all chewed up or kind of like littered with things that people thought were easy but were actually very difficult. We got disheartened, but it really depends kind of on your background. So I mean, people have just kind of like contributed documentation to Rust. People have kind of just written blog posts about it, and these are all cool contributions. You don't have to, add code to the compiler. We always need help, kind of just like adding new tests. Like we just got Steve Padman, who is a good friend of everyone's here apparently, to be our official documentation czar. So he will now be going through, and Doc's really, really nice, but he could obviously use help if he'd like to. So, and also I mentioned this IRC channel. It's just #Rust, on irc.mozilla.org, and there are links to this from the Reddits on the side here. So we have like, how to discuss, join the mailing list, or go to any of these IRC channels. We have some even for dedicated game development in Rust, some for OS development, and for web development. People who want to make like a kind of a web stack in Rust to compete with PHP, etc. Whatever kids use nowadays to write web programs. CGI.
So one of the reasons I wonder about GC is that it makes me wonder about what do you consider like Rust in terms of suitability for like higher level, like we'll say scripting. Like would you use it for scripting some tasks?
So I mean, it's kind of an interesting topic. So like I said before, I mentioned that there's kind of two people coming to Rust: people who want speed but require memory safety, people who require speed want memory safety. And also, I think that Rust is kind of like for the first crowd, people coming from dynamic languages. They really, for me even. So for example, my background is, I tried to use C in college, as you may have guessed from my anecdote. It didn't go too well, and I kind of just got turned off for a long time on all kinds of like this domain entirely. And then I saw Rust, and it seemed like really approachable. So I think that for a lot of people, Rust is going to be their first systems programming language, and probably it'll be their last one too. Because it's a really powerful language. You can do all you need to. But in terms of like using it for scripting, that's what you need. So I know that like Dennis Ritchie uses C for scripting and now Go for scripting. So Dennis Ritchie, Rob Pike also use this too. So so if you're kind of an old school Unix hacker, maybe you really like C for scripting. I don't know. But I think that, I mean, we're not trying to be all things to all people. So if we're not, so we have shebang support, so obviously you can kind of do the same thing you do in Python or Perl, where you can just kind of run a file itself and it will run. But we're not optimizing for that.
So when people get into a new language, they always like the batteries included.
Yeah,
It's
so
like Python and Ruby and Perl, I mean, you can go get your HTTP library and everything. And comparing Rust, which I love the design of, to Go and Swift, where you know they have a big company funding developers to make that batteries included library.
Mm-hmm.
How are we disadvantaged or advantaged?
So I agree. So
Our
in any modern language, you need to come with libraries. People aren't going to, like back in the days of original C and C++, people were willing to content without having a featureful standard library, and it kind of like persists to this day where people are like, I will never use Boost, never, to their grave. But we definitely know, we acknowledge that we need one of these, and we've been kind of evolving our story. Like I said there before, we might not have everything that we want in the standard library by 1.0, but we will have kind of the beginnings of stuff. So we actually just got a call a little while ago from the developers. We're like, well, here are like 7 really, really important libraries that we need for Rust before
They
1.0.
just happen to be very, very hard ones too.
Yeah, so it's like date time, we need some kind of crypto bindings. There are
Coding, internationalization.
internationalization, localization, and like 3 other ones.
HTTP was on
HTTP,
there.
which Chris Morgan is well on his way doing.
SQL was on there.
SQL. So I've seen people claiming SQL, or like, no, but it's really, like, you can't claim it. Just go work on it if they're working on the thing.
I mean, will there be a committee like
A committee?
doing peer review on these to keep them at the same standard?
So I think the
It's
idea
just going to
here
happen.
is that, so our package manager, which we are contracting out to Yehuda Katz of Ruby fame, if you know him, we're a bundler, I think. I don't use Ruby, sorry. Is working on our package manager, and our goal eventually is kind of have a constellation of libraries where even the standard libraries kind of just consists of like blessed packages. The developers have decided kind of like, well, these are really high quality. So we'll just kind of like, everyone who installs Rust will get these by default and guarantee that they're by default, and we'll never like, once they're pulled into Rust by default, we can't obviously tolerate breakage at that point. So we have to make sure that they're high quality. But the idea of doing this all kind of out in the cloud is that we don't need to do with one big monolithic thing. We can do things piecemeal, and it might not be ideal. Purposes of like, well, I'm using Rust, but I need this now, but it's only kind of experimental. But we really don't have time to waste to, you know, kind of like hold back while people are perfecting these libraries over a long period of time. And the idea of this kind of like, with our package manager, the design for it, is that we can deprecate libraries and kind of like version them separately from the language, where unlike say Java, where you have to tie, you know, only release new version standard library with the language itself, you can have these kind of iterative, and in your code itself, you can specify what version of library that you want. And because of our name mangling, you can even have like 10 different versions of the same library, and they'll all live peacefully together. They'll coexist. There's no name clashes, no DLL hell. It's all really cool. Any other questions?
You just said no DLL hell. Does that mean you allow multiple versions of the same library concurrently?
Yes.
Very nice.
So we mangle every symbol exported by a library with the version information of that library. So even if you have, like, you depend on A, and A depends on, you know, B 1.0, and you also depend on yourself, B 2.0, it's no big deal. You can do that.
So there's no strict ABI then?
In terms of a language ABI, do you want to talk about that? I mean,
So it's kind of tricky. It kind of depends what you mean by ABI. If what you mean by, if I can distribute a DLL and then update it without recompiling everyone else, we do not currently support that. It's very tricky to do that in a lot of different cases. But in terms of ABI of like compatibility, like once you're compiled, you're always compatible with the thing you were compiled against. It's more, and like it's generally stable, and like we have this notion of a Rust ABI and a C ABI. So it's like the Rust ABI is this undefined thing you can never touch in the world, but the C ABI is always defined as C, so you can always interface through that. So if you're talking ABI in terms of like where things go in registers and things like that, that's very well defined. If you're talking ABI in terms of symbol names, in terms of like I need to go find this later on in my life, even after I've updated that library, but I haven't updated downstream clients, then that's a little bit of a wishy-washy story right now. But it is the case that like if this library depends on this library version, like A depends on B, very specific version, and then some other library depends on B, a totally different version, there's no sort of clashes between the two of them, and it'll always work out.
Anyone else?
So you mentioned that Yehuda Cat is working on a package manager. How are version dependencies now specified?
I'm not sure exactly the design of that. I mean, I've been following it, but we kind of secretive about it.
You mean without the package manager?
Yeah.
Oh, that, without package manager. So we just have these things called attributes in code, which are basically kind of like, you can put them as metadata in some ways where you just type, you know, hash, and then like, I type version equals 1.0. And it's kind of like, you would have to do a specific thing to opt into our package management scheme, but you do whatever you want with these. So.
And you said C API. What's the kind of C interoperability?
Really good.
Okay.
So like so we have like this really good low. We try to stay close to the middle as much as we can. All of our abstractions that we have are zero overhead. At the basically it's all kind of just like if you want to interface with C, all you need is to import the types that we define as the C types for your library. So for example, like C has variable with types depending on your platform. Rust has by default kind of we just have I32, I64, and then like a pointer size type. So if you wanted to import like you say use libc and then like libc :C int or C long, and then you would kind of cast your types to those and then interface through that way. So that's really only like it's very small wrappers for like interfacing with C. So it'll be a little bit of unsafe code. Like I mentioned, you need unsafe blocks to do unsafe things, which are like calling C code. And I mean like most languages. Every language I can call a C has the equivalent of an unsafe block. It's just that like they used to be called FFI. And we kind of reify this idea and kind of bring language itself for greater safety. So yeah, we love C. We need C because we can't implement it ourselves. So our original kind of like regex implementation was just calling it a PCRE, that kind of stuff. And then gradually you kind of wrap that in a nice interface, and then behind the scenes over time, take out parts of PCRE and put it into pure Rust until eventually it's all Rust and no one knows the difference. So, and there's no overhead calling to C.
What language is Rust written in?
Rust.
It's written in Rust.
It's written in Rust. It was, okay, so in 2011, and prior to 2011, we had an OCaml compiler that was generating a Rust compiler, and it finally bootstrapped in 2011. And now we kind of, it's been a train like that ever since. So we had like, last week's version was compiled by the previous week's version, compiled by the previous week's version. So it's kind of just been like, if you wanted to rebuild Rust from like the original source, it would be quite an ordeal, but it would be possible. But I mean, yeah, it's the wonders of bootstrapping. It's really weird if you think about it. Once you realize how you need to compile the compiler itself 3 times to bootstrap, it's people think we're slow that way too. Because you have to compile LLVM, which takes 40 minutes, and then compile Rust 3 times. Rust is so slow to compile.
Well, the nightlies were a nice addition.
They were, oh my god, yes. Very lovely. Thank you, Brian. Anyone else? Don't be shy. All right, that's good.